Hi guys, this is Miss Carvalho, and for this video, I'm going to talk about how you can use proportions to determine if two figures are similar to each other. So a lot about what we just talked about in the previous video with similar figures, but now we can use proportions to make sure that they're similar figures because the sides have to be in proportion. So let's look in at this first problem, which says determine if two figures are similar, prove that the corresponding sides are proportional. So that means that this smaller figure has to have similar, where are you? There you go. Has to be in proportion to this one. So if this is the little triangle, and I'm going to just start with this side of 5, then what does it correspond to on the bigger triangle, that side of 10? And if that is proportionate to the 10 and the 20, then I know that these two, well, I need to figure out the other side too, but then that's going to tell me if these are similar. So remember when we're figuring out if two fractions are equal to each other, one way is to cross multiply them. So 10 times 10 is 100 and 5 times 20 is 100. So those two fractions are similar. Now let's make sure that that third side is. So I need the 12 and the 24. And I can pick either one of the other sides now that I know that both of them are proportionate to each other. So 10 times 120 is 120, and 24 times 5 is 120. So all of the sides are proportionate to each other. I could cross multiply all of them, and I can use a proportion to make sure that those two triangles are similar. All right, so let's practice. Are these two figures similar? So I'm going to say is 9 to 18, so that 9 is on the smaller figure, 18 on the bigger figure, in proportion to each other if the other two sides that are corresponding are 7 and 14. So we have 9 times 14, which is 126. And is 7 times 18, 126 also. So because I cross multiplied the corresponding sides and they were equally to each other, these two figures are similar to each other. That also means their angles, or corresponding angles, are congruent. Okay, question 2. Are these two figures similar? So I'm going to put this 12, where's the corresponding side on the big? So remember, little, big. So I'm going to put that 12 corresponding to the 36. And then I'm going to have the 10 with the 30. And then to make sure that they are similar to each other, I'm going to cross multiply and make sure these proportions are equal to each other. So 36 times 10 is 360. And does that equal 30 times 12? Yep, that's 360. So are these two figures similar to each other? Yes. These two parallelograms are similar because their sides are in proportion. All right, this third one, let me see if I can make this bigger for you guys. All right, the third one, it looks like this 6 corresponds to the 16. So if this is little and this is big, I'm going to put that 6 with the 16. And then I'm going to see if that is equal to this, how much this 5 and 15 grow with each other. So 5 times 16, cross multiply to make sure fractions are equal to each other, is 80. Is that equal to 6 times 15? 90. So even though these figures look like they might be similar to each other, they are not because their sides are not in proportion. They don't grow at the same rate. Okay, now that we know the corresponding sides have to be in proportion in order for two figures to be similar, we can use that when we have a missing side like this. So if I am telling you that these two figures are similar, you can use a proportion to find this missing side. So this 8, this is 40 degrees, and that's 40 degrees, and that's, does that say 60 degrees? So that 60 goes with the M. So the 8 goes with the 4, and the 6 goes with the 3, so the 10 goes with the X. So if I have on the little triangle the 4, and that corresponds to the big triangle, the 8. And then I have to find this side, so that's on the little triangle, and I'm going to match it to its corresponding side, which is the 10. And now this is one of those proportions where we're solving for the missing side. So the first step you do is cross multiply this times this and this times this and set them equal to each other. So 4 times 10 is 40 and 8 times x is 8x. And then how do I solve this equation? One step, divide both sides by 8. And that tells us that x equals 5. So, and you might have been able to see that a lot quicker using just looking at those two fractions, but I want you to remember how to solve a proportion, because obviously these numbers are not always going to be this easy. It's maybe you could have seen that, okay, well, 4/8 is the same as a half, and so this has to be 5/10, which is good. It's good number sense to use, but the numbers are not always going to be that easy. So remember this cross multiplying thing when we're finding a missing side. All right, so let's look at problem number 1 here. So let's see if I can get my face out of the way. There we go. All right, so number 1, this 4.2 goes with the D, and the 2.6 matches up with the 4.4. So I'm going to set up my proportion as 4.2 over D, because I got to have that D in there. And then the 2.6 has to go on top because I already put my small number, my little shape on the top. And that goes with 4.4. Cross multiply. So 4.2 times 4.4 is 18.48. And then 22.6 times D. 2.6 times D. All right, and then how do I solve this equation? I divide both sides by 2.6. And that will be that D is equal to 7.1. We'll round it to the nearest tens place. All right, so set up a proportion for the missing side and then solve that proportion. Try number 2, so pause here, try number 2, and then I'll have the answer when you come back. Okay guys, so how did you do? After you cross multiply and divide by 15.8, you should have gotten about 6.5. I think it was 6.48 something. So 6.5 is the length of that missing side because those two sides, those two triangles are similar to each other. Notice that 15.6 goes with the 5.6 goes with the 15.8. All right, let's try number 3. Pause here again, try the work on your own, and then come back and see if you got it right. Okay guys, how'd you do? So the 2 should have corresponded with the W, and the 3 should have corresponded with that 4.2. And when you cross multiply them, 3W equals 8.4, divide both sides by 3, and W equals 2.8 feet. All right, let's try this last one. These two figures are similar to each other, and we have to find what J equals. So we're going to set up the proportion. I'm going to put the little over the big again, even though you can set it up whichever way you want to. Pause here and then come back and check your answer. Guys, check the answers. So that 3.15 matches up with the J, and the 1.2 matches up with the 1.6. And if you cross multiply them correctly and divide both sides by 1.2, J is 4.2 millimeters. So that's the length of that missing side. And these two figures are similar, so we know if we set them up as a proportion, we can find that missing side that way. All right, so that's how we can use proportion to find missing sides of similar figures. Hope that helps, guys. Let me know if you have any questions.